So for the function f of x equals the square root of 5x plus 5, we're going to start by finding f of 4. So we're replacing f of 4. We're replacing x with 4. So that would be 5 times 4 plus 5, and the square root of all of that. So that's the square root of 20 plus 5, or the square root of 25. And luckily, 25 is a perfect root, or has a perfect root, I should say. So f of 4 is equal to 5. If x is equal to -3, we'll stick -3 into the function. So that's 5 times -3 plus 5. And that's equal to the square root of -15 plus 5, which is -10. So the square root of -10, and the square root of a negative number does not exist. Lastly, we're going to find the value of x when the function is equal to -5. So it'd be -5 is the square root of 5x plus 5. And we'll go ahead and solve this equation. Square each side. So it'd be 25 on the left and 5x plus 5 on the right. Subtract 5. Subtract 5. So 20 is equal to 5x. Divide by 5, divide by 5. X is equal to 20 over 5 is 4. So x equals 4. Now what we actually should do is check our answer. So whenever you solve a radical equation, you should check your answer. So we're going to go ahead and plug x equals 4 into our original equation. So we said that -5 was equal to the square root of 5x plus 5. That was the equation we were trying to solve originally. And if we stick x equals 4 in, we get 5 times 4 plus 5. We get that -5 equals the square root of 20 plus 5, or that -5 is equal to the square root of 25. But we actually know that this does not work, which means x equals 4 is not a solution. So there is no x value. That's the conclusion. There is no x value where f of x equals -5. Basically, the function never equals -5 anywhere in the domain of x.